All right, so how to answer more questions with events? So how many of you have heard of this term called event sourcing? Quite a few, all right, that's awesome. Well, for those who haven't, let's say that your job would be to keep track of a score for a football match. And the way you would do it, you would have this class called match, and you would have the score, let's say it's a string, and when the match starts, you would like initialize the score to 0-0. Then team 1 scores, you would mutate the state to 1-0, and then team 2 scores, and you would get 1-1. And so you would hold the current state of the application as it is. So in the event sourced world, the difference is that you were actually storing events. So instead of having only the current state, you would handle the match being started. And then you get the 0-0. You would handle team 1 scoring a goal or team 2 scoring a goal. So like that's basically it. So why would you do it? Like why would you have this match started, goal scored, yellow card given, player get ball? Like why? What's the point here? Well, there's actually a lot of benefits in this kind of event-driven architecture. So if you have all these events and this whole history of events in your system, you have basically this whole ability to put the system in any kind of prior state. And you can replay this history and you go back in time to some particular time, and you can create new read models, and you're actually storing the user intentions, which is a good thing. And it's also easier to scale, and since you're like deriving this any kind of state from these domain events, testing is also quite a lot simpler. So at this point you might say that, okay, it sounds all cool, but we have this monolithic SQL server in like 8-10 years. We can't really rewrite our system to an event source way of things, or even parts of it. And that's like my whole argument here. So we could have something alongside of this SQL server that we could add. And that something is complex event processing. So what is this complex event processing? So let's say you would be like a CTO of this kind of PetSafe or Betfair, like online trading website. And then your boss comes to you and says that, it's going quite well, but you would like to be a little bit more responsible, and you would like to avoid this kind of situation with like gambling situations. I mean, this guy has like car keys on the table. It's not looking so great. So we would like to avoid this kind of irresponsible gambler problem. And okay, so let's think about that then. So we need something alongside it, and how about if you just add an event store here? And examples I'm going to show you is based on this event store or Git event store. There are others also. This is an open source functional database with complex event processing in JavaScript. So what does that all mean? Well, first of all, let's talk about projections. For this example, you can just think about the projection as being something that processes a stream of events and sort of splits it to many different events. It can also like hold state inside of it and do other things, but you can just think of it as something that distributes events to different streams. So, okay, let's just pick one event and let's design it here. So let's say we have game ended event and we have some data associated with it. We have a game ID, the timestamp when it actually ended, and some player results. So in this case, the player 1 won 200 euros, and whereas player 2 and 3 both lost 100 euros. Okay, so now if we have our game ended event stream, let's have first of our two projections here. So let's create first this kind of game ended to player projection. So what this one will do is it will split this one game ended projection so that each player has their own stream of events. So this is what it looks like. If you look at the line 1, it says from all. So from all events, whenever we get a game ended event, we take the player results, and for each of those results we create a new stream. So game ended for player, so each player gets their own stream, and then we emit that event to that player. So this is basically what it looks like. On the left side we have the game-ended event, and then we have our protection. So each player gets one of these events. So that's the first protection. And the second one is, okay, let's take an example of this one player now, only focus on one player. And let's say there's 3 games that he plays. First he wins 200 euros, then he loses 300 euros, and finally he loses 450 euros. So not looking so great. So now we need our second protection, and this time it's going to be called irresponsible gambling detector, so really fancy name. And it's also going to have some state inside of it. So quite similar to before, but this time we're going to say from category. So for each of these player streams, again, whenever we get the game-ended event, let's just process it. So we basically collect it. And this is like the whole point here. Let's just calculate how much has the player lost or won within the last 24 hours. And if it's below some threshold, that let's say it's minus 500 euros, then let's emit a gambling detected alarm. So this is our second protection, and this is what it looks like. We have an initial state, games within last 24 hours. We process the first game-ended event. There's one event collected. We process the second one. Now there's 2 events there. And then we have the third one. And now we actually reach minus 550 euros. So now we have our gambling detected event stream where we emit one single gambling detected event. So what's really cool about this is that we can now give this URL to our boss. And hey, this is like live feed of all of our gambling that are being detected. And it's like updated in real time. So yeah, that's basically like an example of this kind of temporal protection you can do. And if you think about our domains like claims handling or financing systems or whatever, usually this kind of complex event processing used for fraud detection, like complex reporting that you can't really necessarily get out of from relational databases that easily. Audit logs, that's basically something that you get for free with event sourcing. And then IoT, like healthcare, for example, it's quite used there. So pick any kind of user-triggered event, because those are usually more interesting. Just then append to an event store and try a bunch of protections. Cool thing about these protections, you can sort of throw them away. You don't have to like keep hold of them. Yeah, thanks.